Okay, so like it says in your notes, imagine that you are on a Ferris wheel. This line here represents the ground. So this is a rather unconventional Ferris wheel because you enter at ground level here. Then, as you move through the Ferris wheel, you're going to go up above the ground until you hit a maximum value. Then you'll travel back down toward the ground until you're at 0. Then you'll proceed to travel down under the ground until you hit a minimum value, and then back up to your starting point, which has a height again of 0. Now on a Ferris wheel, you're going to repeat this motion over and over again for whatever the set amount of time is. So up to a maximum, down to 0, even lower to a minimum, back to 0. This change in height is represented by the sine function. That's not how you spell sine, though. If we plot that over the angles, remember we started here at ground level and we traveled until we hit a maximum. Then we came down until we hit 0. Then we went below ground to a minimum and came back to where we started. Up to a maximum, 0, down to a minimum, back to where we started. So this particular graph is the sine graph. It represents the height for any given angle. If you notice here, my angles are in radians. So as we hit a maximum value, we were at pi over 2 radians, which we could think of as 90 degrees. When we came to 0, we were at pi radians, which we could think of as 180, and so forth. Imagine you're still on the Ferris wheel, and you still enter here, and you have a waterfall that comes and splashes when you hit the top and bottom. So what happens? You start here, and you are as far away from that waterfall as you can get. As you rotate, you become closer and closer. Here, you hit 0. Then you proceed until you are at what I would call a minimum, because we're on the negative side. So we'll call that a minimum. We come back around closer and closer. We hit that waterfall once again. So that's going to be 0. And then finally you come back to where you started, which is again a maximum distance away from that waterfall. And just like when we talked about the height function, this Ferris wheel can rotate over and over and over again. Our angles just keep increasing the more rotations we do around this circle. This horizontal distance is the cosine function. Let's write that as is cosine. So if we look at this one graphically, remember we enter at a maximum as far away from the waterfall as we can get. As we travel upwards, we hit the maximum of the Ferris wheel, the top of the Ferris wheel, and we get splashed, so that's at 0. Then we move away again to a minimum. Back down, this is the bottom of the Ferris wheel where we got splashed again, and back to where we started. And the more times we go around that Ferris wheel, the more we're going to repeat this cycle. So this graph is the cosine. Now with each one of these functions, there are terms that we need to be aware of. The first term is amplitude. And if you look in the two functions, it's represented by A. What amplitude means is half the distance between the maximum and minimum values on the graph. So what we see here, we've got a maximum of 1 and a minimum of -1. So the distance between these is 2, which means that my amplitude is half of that, which is 1. Otherwise, you can think of it as the distance from the center line to the maximum and to the minimum. The next term that you actually do not see in this one is the vertical shift. If that Ferris wheel that we've been talking about were moved upwards, what would happen is that this center line here would move up or down, whatever that value is. Vertical shift is denoted by the C in each one of these. So this whole graph can shift upward or downward depending on the constant term that's added. And the way, again, like I said, I like to think about it on, particularly on a Ferris wheel problem, is if the center line of the Ferris wheel was moved. The last thing that we need to talk about is the period or the cycle of the graph. This is denoted by the letter B. B is multiplied by x inside the parentheses. The way that you calculate the period of a graph is by taking 2 pi over b. The period is the length of one complete cycle, meaning look at where you start, how long does it take you to end back where you started. In this case, it's 2 pi. If I look at this sine graph, here's where I start, because it's the y-intercept, and then here's where I end. Note that I did not say that I ended here, because what I needed to do was go through the entire cycle before I got back there. If you think about this like a Ferris wheel, you had to go through the entire circle to get back to where you started. Same with the cosine graph. So these equations here are the general form of sine and cosine graphs. Based on the A, B, and C values, it will tell you how these graphs should look. So we'll try our first one. We need to graph y equals 2 cosine of x minus 1. So the first thing that I look at is the amplitude. And in this case, it's 2. Then I look at the vertical shift, and in this case, it's -1. Then finally, I look at the period of the graph. And what I do is I take 2 pi over b. In this case, there is no coordinate on x, not coordinate, coefficient on x. So b is 1, the period is just 2 pi. So I sketch in my center line. That's my vertical shift. Now to do the rest of this, what I like to sketch out is what I call a 5-number summary. I want the starting value, the ending value, and then the 3 middle values. This is a cosine graph. It goes from 0 to 2 pi, meaning 0 is the beginning of the period and 2 pi is the end of the period. Halfway in between there is pi, and then I split these again to get pi over 2 and 3 pi over 2. Now I need to know something about the cosine graph. I need to know where it starts. Well, if I think about that Ferris wheel with the line down the center, I realize I start at the maximum. So generally, I would say I have a maximum of 1 down to 0, -1, 0, 1. However, I have an amplitude of 2 and a vertical shift of -1. So the first thing that I'll write down is my vertical shift. So essentially I'm just going to deduct 1 from each one of these values. So this becomes 0, -1, -2, -1, 0. And just to make this a little easier to read, I'll write that this one was cosine of 1, or cosine of x. This one's cosine of x minus 1. Finally, what I need to do is I need to apply this amplitude. Now, the amplitude is really only going to affect the max and minimum values. The places where it actually touches the center line will stay the same. In this case, we touch the center line at -1. So these two values are going to stay the same. When I look at the maximum and minimums, I need 2 above the -1 and 2 below -1. So for this 0 spot, which is this spot here, I need to be 2 units above -1. Well, that's +1. For pi, I need to be 2 units below -1, which means I need to be at -3. And then for 2 pi, I again need to be 2 units above -1. So now I can plot these points. The thing that I did not do was talk about labeling this graph. I tend to have my x value go from -2 pi to 4 pi. And I tend to go in increments of pi over 2. So there's pi over 2, pi, and I think of this like 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, and so on. When you move in the negative direction, you do the exact same thing. Now I'll plot these points. So start at 0, at pi over 2 we're at -1, -3, back to -1, and back to 1. This will repeat itself. We've only completed one period of this graph, so we do the same thing again. And we go the same backwards. Now when I connect these dots, I'm going to make the curves smooth. I'm not going to make them pointy. It does not have to be perfect, but if it's pointy, it will be marked wrong. Remember to include arrows because these graphs move on and on. Okay, for this one we will graph the sine function, and we again start with amplitude, which is 3. There is no vertical shift, but we do need to look at the period. In this case, it's 2 pi over 2. So we simplify that. That means the period of this graph is pi. So when I create my 5-number summary, I have to go from 0 to pi because it will go through one cycle in pi units. I split that in half. Like this. Now this is the sine function, so I will just start with sine of x. Sine starts at 0, up to 1, 0, -1, and back to 0. Now I need to add in my amplitude. And this is probably sine of 2x, really. So that means that all my zeros stay the same. My center line stays the same. But my max and min have to be 3 units off of that center line. So that brings us to 3. This is 0, -3, and 0. So there's pi over 2. That's not right. And again, I move backwards. This one's going to be a little bit trickier because we have these values that are in between our tick marks. But we can still make this work. So at pi over 4, we're up at 3. And then we're down here. At 3 pi over 4, we're at -3, and we're back. Now we will repeat this. As you notice, this is a much skinnier graph than what we saw last time. But we can repeat this. And also backwards. And again, we connect these with curves rather than pointy lines. And it's not perfect, but you can see what the graph is supposed to look like. For this problem, we'll go backwards. We're given a graph and we have to write the equation for that graph. So the first thing I need to do is figure out where my center line is. I see I have a maximum at 8 and a minimum at 0. So my center line has to be halfway between 8 and 0, which is 4. So I will sketch in my center line. This tells me that I have a vertical shift of 4 units. Now, the fact that my max and min are now 4 units away from this center also tells me that my amplitude is 4. The third thing that I need to look at is the period of the graph. If you will notice, these are not in terms of pi. That's okay. It does not have to be in terms of pi. But what we need to remember is that the period of the graph is equal to 2 pi over b. So what we need to do is we need to figure out the period of this graph. If I start here at 4, I go up. Yes, I have hit 4 again, but remember I haven't gone through a full cycle, and I'm back. So the period of this is also 4, which means that 2 pi over b has to equal 4. Well, we need to solve for b. So in order to do that, that means that the b term of my equation is equal to pi over 2. Now I need to think about, is this a sine or cosine? The way that you tell is by looking at the y-intercept. If your y-intercept is the center point of your graph, it's sine. If y-intercept is at a maximum or a minimum, then it's cosine. So in this case, it's sine. The next thing we need to do is pay attention to whether or not it's positive or negative. From my center line, this increases. That tells me it's positive. If it had decreased first, it would be negative. So we now have a lot of information, but amplitude is 4. This is sine. My b term, pi over 2 times x, add in my vertical shift. There's my equation. Okay, last one. So again, I have a graph, I need to write the equation. I see that my maximum is 3, my minimum is 1. So my center line is halfway between 3 and 1. In this case, it's at 2. That center line tells me my vertical shift. For the amplitude, I look at the distance between center line maximum, between center line and minimum. Here, I can see that the amplitude is equal to 1. Finally, I need to look at the period of the graph. I'm starting at a maximum, down, and ending at a maximum. So I complete one cycle in pi units. So I remember that 2 pi over b is equal to the period. So 2 pi over b has to equal pi. 2 pi has to equal pi times b, which means that b in this case is equal to 2. Finally, I will decide whether it's sine or cosine. This graph starts at a maximum. It's cosine. If it had started at a minimum and traveled up first, that's okay. That would just mean that the graph was negative and our amplitude would be a negative value. But for us, it starts at its maximum, so it's positive. Amplitude is 1. I don't need to write in an amplitude of 1. My b term is 2. My vertical shift is positive 2.